Okay, so welcome to grade 5 and the 12 weeks programme. So we're on module 1, lesson 1. Hopefully you found this document. I'm going to talk you through the document and help with any parts that I think might need it as we go through. Okay, so module 1, lesson 1, introduction to basic number. Now, before we even start any of the teaching, there's one thing that I think is so important. When students come to me in year 7, at the school I teach in, we start getting this sorted right from the offset, and that's times tables. So you started learning times tables in year 2. You are now in year 11. If you're joined this course in year 11 now. It's so important that you can recall times tables. It helps with fractions, it helps with prime numbers, it helps with multiples, it helps with factors, it helps with everything. And there's something with learning when we're teaching you is we try to not overload your brain. That means your brain can't take on too many things at once. So if we're trying to teach simplifying fractions, for example, or addition of fractions, if your brain is focusing on the times tables aspect because you're not confident with your times tables, then your brain, your memory is not going to take on the information it needs to. So I don't care how you learn them, right? You can use games. There's so many games online. I'll put a few links in here so you can try them. Ask someone to constantly test you. Car journeys, just write them down, have them read out, put them up on your wall, print off a 12 by 12 table grid so you can quickly recall them, quickly look at them. And in actual fact, if you're not confident on your times tables, I do suggest you do print out a grid to use as we're going throughout this, because it's something that, as I've said, you're not going to be able to take all the information on you need to if you are not confident with them. Okay, as I've said here, trust me, knowing them will really make a difference in the long run. After all, both me and you want to make this as quick and easy as possible. Don't waste any more time trying to do questions while working with this knowledge block, okay? So the things that are taught in the following lesson are the main foundations that you need to have solid so that we can then build on them in future lessons. You must understand these before moving on. That means if you don't get them the first time, look back over it. If you don't get them the second time, look back over it. Keep going, please, until you are confident. So the first one is the order of operations. You might also be know that as bid mass. Multiplying, dividing by 10, 100, 1,000, etc. Okay, there may be a few more bits on this when you next listen. So number 1, order of operations. So bid mass stands for brackets, indices, division, multiplication, addition and subtraction. Now those two parts in brackets, division, multiplication, and the addition and subtraction, is because they have the same power as each other. They have the same order as each other. So if you had a calculation with division and multiplication in it, you just work from left to right. Okay, so what do we mean by that then? Let's have a look. So you can see the first calculation there. Let's have a look at how we would sort that one out. So what is 3 minus 1 squared multiplied by 2 subtract 12 divided by 4. So we've said the order in which you should do them, you should start with the brackets first. So you will see it's the brackets that I have done first. So 3 take away 1 leaves you 2, and then we're doing 2 squared. That I'm going to edit to be a little 2 up there because there's been an error there. So we've got 2 squared multiplied by 2 subtract 3, because 12 divided by 4 is 3. So I've replaced the 3 subtract 1 with the 2 and the 12 divided by 4 with the 3. Right, so the brackets have done. So if I was doing this in a question, I would then tick off the brackets. I would then move on to the indices. So the indices is the same as the powers. So something that's being squared is a power. 2 squared is the thing I would do next. And 2 squared is 4. So we're then doing 4 multiplied by 2 subtract 3. So next thing we've got in there is multiplication and subtraction. So we've done the indices, let's tick them off. Now my next things are the division and multiplication. So let's do the 4 multiplied by 2, which gives me the 8. So we've done the multiplication. And finally, the addition and subtraction would come last. So 8 subtract 3 is 5, giving us the final answer of 5. Now, if we had not done that in the correct order, we may get a completely different answer, okay? So make sure you follow the order of operations or bid mass. Right, I'm just going to pause that for a minute so I can move my pen down. And we'll go on to the next section. Okay, next up then we have multiplying and dividing by 10, 100 and 1,000. So multiplying is making the number bigger, isn't it? If you're multiplying by a number greater than 1, you're going to be making the number bigger. So you're moving the decimal point to the right of the number because moving it to the right is going to make the number bigger. For example, let me get my pen tool up again. Let's have a look. Let's clear what's on that page already. We don't want that anymore, do we? Let's just delete that. Oh, I'm wanting to go. Okay. So imagine I had the number 36. Now there is always an invisible decimal point after the number. 36 is the same as writing 36.00. So if I wanted to make that number bigger, the decimal point would be going that way. If it moved one place, the number would become 360. 2 places, the number would become 3,600, etc. So moving that decimal point to the right makes that number bigger. Okay, so when dividing, if you're dividing by a number, it's making the number smaller, right? So unless you're dividing by a number less than 1, that is, but we're just dealing with larger number. We're dealing with the numbers 10, 100, 1,000. So let's start again with the number 36. I'm going to put the decimal point in with some zeros. And this time we're saying we're dividing and we're moving the point to the left. So if you're moving to the left, if you moved it one place to the left, you would end up with the number 3.6. If you moved it 2 places to the left, you would end up with 0.36. You would never say 0.36 though. You would say 0.36. You would actually put in a 0 and a point to say 0.36, okay? So here we go, examples. 42 multiplied by 100. Now, we take into account however many zeros there are, and that's the number of places that the decimal point is going to move. So because there's 2 zeros here, it's going to be moving 2 places to the right. So we start with the number 42. 42 has a decimal point here, and we're moving it 2 places. 1, 2. Which is how we've got the answer of 4,200. The decimal point would now be here. Obviously, it's an integer. We don't have to put that in, but the number now would be 4,200, okay? Because it's multiplied, it's got bigger. It's gone from 42 to 4,200. Right, dividing by 100 then, the number is getting smaller. So once again, the invisible decimal point is here, and there's 2 zeros after the 1 again, so we're moving it 2 places. So one place would be 56.2 and the second place would be our answer, which is 5.62. Okay, now so just to be clear, if it was 10 you would move it 1 place. If it was 100 you would be moving it 2 places, and if it was 1,000 you'd be moving it 3 places. Now this also links in, don't worry about this too much now, we're going to be bringing it up in a later module when we talk about powers, but 10 is the same as, could be written as 10 to the power 1, so that would be we'd be moving it 1 place. 100 is the same as 10 squared, or 10 to the power 2, that's the 2 places we'd be moving it. And 1,000 is the same as 10 cubed. That's 3 places would be moving it. So if your calculation, rather than say 42 times 100, it could say 42 times 10 squared, because 10 squared is the same as 100, as we've said, and that would still mean you'd be moving it 2 places. 1,000, 10 cubed, you'd be moving it 3 places, etc. Okay, so that's multiplying and dividing by powers of 10, 10, 100 and 1,000.